Today we are going to be talking about the third and final chi-square test. We've talked about goodness of fit, where we test breakdown of one population against a claim. And we've talked about chi-squared for homogeneity, where we test to see if two or more separate populations have the same breakdowns. The third one is a test for association. This is one population where each person that we sample we put into two categories. So that is what we are testing today. So first of all, this is the chi-squared test for association. Since it always comes back to burritos with me, we're going to discuss this topic. We are going to sample a bunch of people, which looks like we have 385 people. We are going to determine, is there any association between what their favorite burrito place is and what they feel is the just most important ingredient, and see if those two things are related. So maybe our point would be, I like salsa so much, so therefore I chose one, if there's any relationship. If there's no relationship, then this test should prove that. So let's start with the hypotheses. The null hypothesis is going to be no effect or no change, which means in this case, that means there is no association between favorite burrito place and key ingredient. And that means our null is going to be, our alternative is going to be there is an association, yada yada, all the same words. Okay, another way to phrase this, we'll just kind of keep this as our standard. You could also say the null is that burrito place and key ingredient are independent, and that they're not independent for the alternate hypothesis. We're kind of, the conditions are the same as they were for the last two-way table, that our counts are big enough, which they are big enough, and that it's a random sample. We're just kind of assuming that's the case so that this can be our context. Students talk about burritos, right? So once you get your hypotheses set up, everything else is going to be the same. You're going to need to know your expected counts for each one of these cells in this table. And again, we can in my class we can do this, and we'll put the expected on the other side of the slash, just to say this was drawing a whole new table. Not necessarily going to do that on the AP test, but on homework that's fine. We're going to find the chi-square statistic, use the chart if we're doing it by hand. Or in other words, the other way to do it is going to be on the calculator using matrices. So I'm going to talk about finding the one expected count, and then I will zoom to the future and do the rest of it. So how many people do we expect to like Moe's and think queso is the most important? It's the same process. It's the row total times the column total divided by the total. So 134 times 60 over 385. You can use your list to do these if you want. We're going to use the matrices anyway. This will work just fine. So we would expect 20.88 people to be there. One thing I want you to notice is this doesn't have anything to do with the most popular place. Okay, Chipotle obviously is the most popular one in this case, because these were obviously some educated burrito lovers. But that's not the point. The point is, based on this breakdown, what do we expect to see there? We would expect, if there was no association, 20.88. And then we would find the rest of them in a similar way. So I'm going to pause and find the rest of them. You can just copy them there. Just a moment. Okay, so in the same method, I calculated all of the expected totals. And you can kind of look through and see where the big differences are. Most of them seem to be pretty close. The salsa and chipotle was off by about 7 people. We saw 7 more than we thought we would. The queso at chipotle was low, which might make sense because they don't have any. Qdoba's queso, we saw 40 and expected 34. So without even doing any testing, you can already kind of get an idea of which of these cells are going to contribute the most to the difference, to the chi-squared value. So if we're doing this by hand, we would go through in 9 separate times. We would do observed minus expected squared over expected, add those all up, get a chi-square value, go to the table using 4 degrees of freedom because it's 3 by 3, so we multiply 1 less than each of those dimensions. So that would be a 2 by 2, or a 2 times 2 is 4 degrees of freedom. Anyway, we're going to, for the sake of speed, do this in the calculator. So what I have done is I've gone and entered into my matrices, the observed and the expected. Matrix A, there are my observed values, and matrix B, here are my expected values, and both of them match the same. Each cell in the chart has an observed and expected. So I have 2 3 by 3 matrices, 1 for observed, 1 for expected. Now when I go to do my test, I go to stat tests, chi-squared test, and observed in A, expected in B, and calculate. So we get a chi-squared value of about 4.8. We get a probability of almost 31%. I'm going to do that again to draw it. I like the picture on these. It's drawing the other graphs I have entered in right now, but should eventually draw my chi-squared distribution. And we should see quite a bit of area shaded in. Yeah, we've got 30% of our area shaded in. So what does that mean? That p-value is interpreted the same way it always has. The steps of our test are the same. We do our hypotheses, which are here. We do our conditions, which, like I said, we're kind of omitting those for the time being, but they're still important. We carry out the test, and this test gave us a chi-squared value and a p-value of 4.8 and 0.3084. So, and then you make your conclusions. So my conclusion is I fail to reject the null. There is not evidence of an association between favorite burrito place and preferred key ingredient. And there are different ways that you could word that would be acceptable, but you have to fail to reject, and you need to use the context. So basically what we have proven is it doesn't matter what kind of burrito you like, Chipotle is going to be the best. Really, that's the bottom line here. So there is our chi-square test for association. Mathematically, it's very similar to the test for homogeneity, but the setup, the reason you would use it is different. We're going to use homogeneity if we have different populations to see if they have the same breakdown. In this one, we're going to have one population, and we're going to take subjects and categorize them by 2 variables, and then proceed with all the same calculations, whether by hand or calculator. It's still the same. Okay? So, I will see you in class. This is Young, and I'm training to become a cage fighter.